Hello friends, in the last video we have stopped with this derivation to determine the horizontal distance using the tachometric principle, right? So D is equal to Ks plus C. That is called the distance equation, and the K is equal to F by A is the multiplying constant or stadia interval factor, and the constant F plus dc is equal to C is known as the additive constant. Right, this we have determined by the concept of a Lenz's formula we have used, right? To calculate the multiplying constant K, measure a known distance d1, say the known distance, and take the intercept S1. That S1 can be determined by subtraction of top reading minus bottom reading on the staff kept at the point, the line of sight being horizontal. It is more important, it is horizontal, using the equation. So now the distance is known, the top and bottom reading difference gives the S1, so the leftover to this K and C, right? So for the average value, similarly for the another known distance D2 and D3, if you are making, if you are able to solve those equations, you will get the value of K and C, right? See here, if the instrument is set at and for the known distance 10 meters, say the staff is held and the reading was taken, the top, middle, bottom, and the staff is then moved to another point for the known distance 15 meter, in that also top, middle, bottom, and another known distance say 20 meter, another top, middle, bottom. Now for distance 10 meter, capital D is equal to K1 K S1 plus C. What is S1? A2 minus B2, that you will get. So the left out is 10 is equal to K, S1 will be the difference plus C, first equation. Similarly for second equation, 15 is equal to K S2 plus C. What is S2? A1 minus A2. Similarly A minus B for the third equation, 20 is equal to. If you are able to solve this equation, you will be able to get the constant value, right? So that was explained here, D1, D2. From that you can obtain the K. If you substitute K in this, you are able to obtain the D, obtain the C, right? So now example problem. A tachometer has a diaphragm with 3 crosses spaced at distance 1.15 mm, right? Spaced at. The focal length of the object glass is 23 centimeter. See, the units are different, mm, here centimeter. And the distance from the object glass to the trunnion axis is 10 centimeter. Calculate the tachometric constant. What was given? The focal length F is given 23 centimeter, and the distance from the objective glass to the trunnion axis, the small d, is given as 10 centimeter, and I is equal to Y, here it is 2 into 1.5. they have given has spaced in top, middle, bottom. The spaced distance between top and the middle is 1.15. then for the I is equal to 2 times 1/2 is 1.15, 2 times 2.30 mm. So try to convert to the common unit. Here all are centimeter, so convert this also into centimeter. Substituting values in the standard formula, so we know F by I gives the K, so focal length is here, I is also here. Now you get the 100. F plus D gives the additive constant, it is 33. So right, so F is 23 and D is 10, 33 centimeter. Generally it will convert to the meters only, right? So here it becomes a constant, the unit also get cancelled, but here it will be additive. Try to convert to meter. So the constants you are able to get. right? This is one way. If they give the data of focal length, stadia intercept, staff intercept, like that, right? Next problem, the stadia readings with horizontal sight on a vertical staff held 50 meter away from a tachometer, where 1.284 and 1.780. The focal length of the object glass was 25 centimeter. The distance between the object glass and the trunnion axis of the tachometer was 15 centimeter. Calculate the stadia interval. What is stadia interval is I. What was given here is small d, and the capital D is given as 50 meter, and the focal length f is given, and thus stadia readings. This means top and bottom, right? So we know the equation, distance equation is equal to D is equal to f by I s plus f plus d. The d is 50 meter, focal length is, so now the d becomes the decision maker. In unit is meter, so try to convert all in meter. So f is equal to 0.25 meter, d is equal to 0.15 meter, s is equal to staff intercept is equal to top minus bottom gives 0.496. Substitute all the value. Phi is equal to f by I, 0.25 by I we don't know, into S you know 0.496, plus f plus d you can substitute. The one and only I is left out. From that you are able to get the I value, right? 2.5 mm. Here you have obtained meter. You can show it as in mm also in answer, no issue, right? Thus you are able to get the value with respect to the constant to the parameter, or parameter to the constant, right? Next is the important one, distance and elevation formula for the staff vertical. That is, till now we have seen the telescope is in horizontal angle. Now we are going to rotate the telescope either upward or downward, so it is an inclined line of sight. So let P be the instrument station, Q be the staff station, M is equal to position of the instrument axis, O optical center, A, C, B the points corresponding to the readings of the 3 has, and so A, B is the staff intercept, I is the stadia interval, theta is the inclination angle, line of sight from the horizontal, L, capital L is the length, MC measured along the line of sight, along the inclined line of sight, the length, right? So, and capital D is the actual horizontal distance between the instrument and the staff. V is the vertical intercept at Q between the line of sight and the horizontal line. H is equal to height of instrument. R is the center hair reading. Now the new notation is come. R is the central hair reading. You have to remember this. H is the height of instrument. Beta, angle between the two extreme rays corresponding to stadia as we can see with respect to the picture, right? So this is the angle beta between the two extreme rays. This is the angle of inclination of the telescope, theta. This is the optical center, and this is the instrument center point, vertical axis point, and it is dropped in the ground. It is the position of, right? So, and this is the height of instrument H. This is the horizontal line of sight, but this is the inclined line of sight. From this point to this point is the length L, and ACB is the readings noted over the station Q by holding the vertical staff exactly vertical, right? The line of sight is inclined to this. You have to remember the diagram. Here the staff is vertical. So the center reading from the ground is denoted as R. From the horizontal line of sight to the center reading, you have to remember it is V, vertical difference, right? V. And if this become a right angle triangle and this become the theta, and its exterior angle, this also become theta. We will see how it is. Now we are need to determine the distance d, right? So that is the ultimate aim by the concept of tachometric principle. Now for that, draw a line a dash c b dash, a dash c b dash, such that this line must be exactly perpendicular to this line of sight, normal to the line of sight OC. So angle a dash c, a dash c, and this becomes the one more angle. It is 90 plus beta by 2. How it is beta by 2? See, this is beta. For this triangle, this becomes beta by 2, right? And it is a right angle triangle, means this is beta by 2, means this becomes 90 minus beta by 2 here, right? So, and this also 90, means here again this becomes the 90 plus beta by 2. Let's see how it is. So this angle becomes 90 degree minus beta by 2. So this becomes also, let's see, being the exterior angle of the triangle COA dash, right? So exterior angle of the right angle triangle will becomes this angle, it is 90 degree plus beta by 2. Similarly, from triangle COB, see here COB dash, same principle. Here also this becomes theta, and the angle OB dash C is equal to angle B dash C is equal to 90 minus beta by 2, right? So this is also minus only. Since beta by 2 is very small, how it is very small? Its value being equal to 17 minutes 11 seconds for the constant k is equal to 100. So the angle A dash C and angle B dash C may be approximately equal to 90 degree. Since beta itself this much by 2, it became more or less. So 90 minus this or 90 plus, it is more very near. So we can consider approximately equal to 90 degree. So the angle A dash C and the angle B dash, let it be 90 degree. From triangle AC A dash, what is AC A dash C? AC A dash C is equal to AC cos theta, that is cos theta is equal to A dash C by AC. Now we have obtained the A dash C. Similarly, A dash B dash is equal to AB cos theta. Here you know the AB is the staff intercept S, right? Top minus bottom gives the S. That we have represent here S cos theta. Let it be A, first equation. Since the line A dash B dash is perpendicular to the line of sight, the imaginary line we have drawn to OC, equation D equal to Ks plus C is directly applicable to this line, So this becomes the horizontal distance and this becomes the exact staff. So horizontal distance, and this one is the inclined one. So in position of D, this becomes L. So L is equal to Ks plus C. That principle can be applied here, right? So MC, what is MC? So the point MC is equal to L. So the L can be obtained by K. What is S here is the staff intercept. For here the staff intercept is A dash B dash, that distance, plus C. What is A dash B dash? Already we have obtained here is S cos theta. So Ks cos theta plus C. what we have obtained is L is equal to Ks cos theta plus C. Let it be another equation. The horizontal distance D is equal to, how we can get, see, the distance, this can be obtained, say cos theta is equal to opposite by hypotenuse, right? And here the L is involved. Cos theta is equal to adjacent D by L, right? So we require D, so D is equal to L cos theta. So that is D is equal to L cos theta. L, what we have obtained, Ks cos theta plus C into cos theta. The product gives the distance equal to Ks cos square theta plus C cos theta, right? So next we need to determine the vertical difference. How we can get the vertical difference? V, say I required this V, so say sin theta is equal to V by L, we required, so V is equal to L sin theta. So L sin theta, and L you know, Ks cos theta plus C into sin theta. So Ks cos theta sin theta plus C sin theta. This you may remember, 2 sin theta cos theta is equal to sin 2 theta. Here the 2 is left out, so sin 2 theta by 2, right? So the V is equal to Ks sin 2 theta by 2 plus C sin theta. So thus 1 and 2 are the distance and elevation formulae for the inclined line of sight. If it is here, if it is in the vertical elevation or depression, the same equation can be adopted, right? But when to determine the RL, we have to say when the angle at elevation, the line of sight has an angle of elevation theta, as shown in figure. We have elevation stuff is equal to elevation of the instrument plus H plus V minus R. What is plus V minus R? See, elevation plus H plus V minus R, right? So this is the elevation of this point you can get, right? So that is given. If the angle at depression, instead of this, if the point is in lower ground, how it will be? The same elevation of P plus H. Here the V becomes the downward, so minus V minus R, right? So that is the changeover. You try to check for this in the diagram of any book, you can get it, right? I hope you understand, friends. Thank you.